Hi friends, welcome to my channel WinChem. Now we are going to see increasing order of the acidity. For some of the compounds we are going to see and we have to finalize the order, which is the first and which is the second we have to finalize. Nearly we are going to see nearly 20 compounds. After this video, you are very well about, very well how to do the acidity order. Okay. Before starting the problems, I'll just tell you the tricks regarding in that. Okay. What is the acidity? Acidity means the proton leaves from the compound easily. Then that is, we call it as that compound is having more acidity. So that is easily lose the proton. That compound which easily lose the proton, then that compound is having acidic compound. And if the compound undergoes resonance structures, then that is acidic compound. If the compound is having electron withdrawing groups, what are electron withdrawing groups? Fluorine, chlorine, bromine, iodine, and some of the NO2 groups, cyanide, acid groups, that is carbonyl groups, and sulfonic acid. These groups are electron withdrawing groups. If these groups are present in the compound, it increases the acidity of that compound. So that is also comes first. And the pKa value. If pKa then the acidic character is high. Okay, if the pKa value is more, then the acidic character is decreases. So, okay, pKa value should be less, then only the acidic character should be more. Okay, so pKa value should be less, Ka value should be high, then only acidity more. Now we are going to see the problems related to the acidity. The first problem, from the basic I am going to teach till the higher one. Okay, the first one is acetic acid and ethanol. We know acetic acid and then ethyl alcohol, which is having more acidic. Here acetic acid is there. Acetic acid means it undergoes resonance structure. Okay, after removal of this, it undergoes resonance structure. So this is more acidic compared to the ethyl alcohol. The second one, trichloroacetic acid and then acetic acid. Okay, trichloroacetic acid and then acetic acid. See here 3 chlorine atom is there. If electron withdrawing group is there, these 3 chlorine atom is what? Electron withdrawing group. If electron withdrawing group is there, what will happen? The acidity will increases. If electron withdrawing group is there, acidity increases. So this is more acidic than this. This is also acidic compared to this. If electron withdrawing group is present in this compound, the acidity will increases. Why it increases? It withdraws the electron towards itself. Okay, it withdraws the electron towards itself, and what will happen? This proton will easily away from the oxygen atom. It decreases the negative charge on the carbonyl atom, so the proton easily leaves from that. And the third one is ethane, thiol, and ethanol. Ethanol, we know, CH3, CH2, OH. Ethane, thiol is, what is that? SH, that is thiol. Okay, this is thiol. If you see these two compound, this is more acidic compared to this. Why? Why this is more acidic? This SH bond is very weak bond, and it easily remove from the sulfur. Why it is easily removed? This p orbital of S and 1s orbital of hydrogen, this bond is not completely overlap. It's a very weak bond. This overlap is not that much good, so this will easily cleave it. Okay, easily remove from the PP bond. So this bond is very weak, so it easily cleaves. So this is more acidic compared to the OH bond. Here the OH is very strong bond compared to the SH bond. And the next question, fourth question is benzoic acid, acetic acid. It's very easy. Now I'm little bit move to the benzene ring. With the benzene ring, I'm going to explain acidic character. What will happen with the benzene? Here the resonance structure is there. Compared to this benzoic acid, the resonance structure of this acetic acid is less. what will happen? This resonance structures moves towards the benzene. So this will also increase the resonance structure. This will also give 3 more resonance structure. So this is a more, if resonance structure increases, what will happen? Acidic character increases, resonance structure increases, acidic character increases. And the fifth one, phenol with ethyl alcohol. Here with acid I have explained that. Now phenol with ethyl alcohol, same one, the same reason for this also. What will happen here? The phenoxide ion, this will easily cleaves and it forms phenoxide ion. This phenoxide ion undergoes the resonance with the benzene ring. So this is more acidic compared to this ethanol. And the sixth one is para-nitrophenol and phenol. Both are phenol, but I am comparing the two phenols. One is para-nitrophenol, another one is only phenol. We very well know about this. Actually, we should not write like this. N should be here and 2. Okay. This NO2, we know very well, this is electron withdrawing group. Okay, this is electron withdrawing group. This increase the acidic character compared to this phenol. If phenol alone will also increase, but this NO2 will, what will happen? This will additionally, it will, that resonance structure additionally it moves towards this side. Why? How it moves towards? See, this resonance structure will move here also, and it will go here also. Resonance structure will move. So 2 more resonance structure will increase. So this is more acidic compared to this. And then 7th one, acetic acid, CH3COOH, 2-methyl propanoic acid. See, propanoic acid, 2-methyl is there. And third one, 2,2-dimethyl propanoic acid. Now listen to this. Here there is a no electron withdrawing group. Instead of that, what is happening here? Methyl group is there. That is a little bit, what is that? Electron releasing group. Electron withdrawing group increase the acidity, and electron releasing group decrease the acidity. So here electron releasing groups are there, decrease the acidity. So this is having a 3CH3 group. The 3CH3 group releases the electron. What will happen here? It is not decreasing the negative character of the oxygen. So it is not easily leaves this hydrogen. Okay, so this is more basic character. It's not an acidic character. It is not leaving. So this comes to the third. Okay, and next to that, this is having 2. Compared to that, this is having 2 methyl group. So this comes to 2 and this comes to first place. Okay, and this 8th one, butanoic acid, chlorobutanoic acid. 8th one is butanoic acid, CH3, CH2, COOH, first one. And second one, 2-chlorobutanoic acid. Third one, 3-chlorobutanoic acid. Compare this. If chloro is present means it increase the what is that? It increase the inductive effect will be increases, and it easily leaves the proton, and this is the increase the acidic character. Increase the acidic character. Here also chlorine is there, here also chlorine is there. But here this is the 1 carbon away from that, but it is very closer to that. If it is very closer, the inductive effect also very close, but it is away from that, the inductive effect falls off with the distance. Keep it in mind, the inductive effect falls off. Okay. It will reduce, falls off with the distance. Distance is there means it will reduce. But here, see, there is distance is very less. This is higher compared to this. Here there is a no electron withdrawing group. So it comes to the third position. And the next question, this is the third. Okay. 9th question is 3-chloropropanoic acid. Sorry, chloropropanoic acid. and 2,2-dichloropropanoic acid and 2-chloropropanoic acid, 3-chloropropanoic acid, okay, 3-chloropropanoic acid. Now this is the three things. Which comes first? Everywhere electron withdrawing group is there. In the first case, as I said, in the first case, chlorine atom which is close to the carbonyl group increases the acidity. Here see that how many chlorine atoms are there. Here 2 chlorine atoms is there, so this will increases more. There is this acidic characters increases more. Why? How it? Because of the inductive effect. It what is that? Inductive effect towards inductive effect will be there. So what will happen? It removes the electron towards itself, so this hydrogen is easily removed from here. This goes to first place, and next one is this one, and the third one, because of the distance, it reduces the acid character. And the 10th one, propanoic acid, 2-fluoropropanoic acid. Fluoropropanoic acid, 2-bromopropanoic acid, and then 2-chloropropanoic acid, and then acetic acid. This is the 10th question. Okay. Here everywhere electron withdrawing group is there with acetic acid also there. If electron withdrawing group is there, then acidic character increases, as I said earlier. Okay, that is the trick number 3. But these three are electron withdrawing group. How to compare these electron withdrawing group? If electron negativity increases, it increase the acidic character, increase the acidity. Okay, compared to these halogens which is having more electronegativity, fluorine is having more electronegative than chlorine and then bromine. So this comes to the first place, and this comes to the second place, and this comes to the third place. Acetic acid is 4th one. Okay, the electronegativity also plays a role in acidity. Keep that in mind. I didn't mention over here. If electronegativity is there, that is also plays the electronegativity is there, increase the acidic character. And the 11th question, so this 12th question, trifluoroacetic acid, chloroacetic acid, fluoroacetic acid, and acetic acid. This is also similar to that. What is happening here? Trifluoro is there. Trifluoro acid is there, and then chloroacetic acid, fluoroacetic acid. Okay, here fluoroacetic acid, and then simply acetic acid. Compare all the 4. As usual, this is first one. As I said earlier, 3 fluorine atom, which is a highly electronegative fluorine atom, and 3 is there, so this comes to the first one, and the next one goes to 1 fluorine atom, and third place goes to the chlorine, and then only acetic acid. Okay, next sum, 12th one, oxalic acid, COOH. Now I'm going to compare only as acids. Oxalic acid, malonic acid which contains a 1 CH2 group. Okay, and then succinic acid which contains 2 CH2 group, and then glutaric acid which contains 3 CH2 group. From the structure itself we can easily know which one is it. But most of the time they won't give the structure like this. They will give you like the name. You have to find the structure. If you know the structure, you can easily find the answer. You very well know the oxalic acid, there is a no CH2 group is there. So as I said earlier, the inductive effect, what will happen? And if the distance is there, it falls off the acidity. Okay, if the inductive effect falls off with the distance. Here, see, here the distance is too much. So this will becomes as a last one, and here it reduces. This is third one, and it 2, and it was the 1. Compared to these one, this first acidic character goes to oxalic acid. And the 13th sum, acetic acid chloroacetic acid, thiolacetic acid, thiolacetic acid, fluoroacetic acid. Now you will compare. Which one is first? Whether this chlorofluoro, if you in these two, you know very well, this will comes first in these two. Okay. If thiol and fluoro is there, which will come first? That is also same. This will come as first. Electronegativity is there means that is the first preference. You have to give that, for that is a first preference, and electronegativity for the second one is 2, and then this third, and then it becomes 4. Okay, if we compare these electronegativity, that is halogen, these halogen, this is more than the thiol. Okay, compared to this, this is more. This is more. Halogen is more than the thiol. If you compare this with the alcohol, this is more than the alcohol. Okay, if you compare alcohol with the thiol, thiol is more than the alcohol, because this bond is a strong bond, this bond is a weak bond, it easily cleaves. This is more. Okay, keep it in your mind. And 14th one, ethanol acetic acid, very easy. Okay, ethanol acetic acid phenol. So very simple, you can easily say by yourself. Ethane. What is that? Which one will comes first? If resonance structures, everything is there. Okay, even then you have to see properly, and you have to say. If you add a base, then only it will cleaves and it form. But here this will easily cleaves this for hydrogen, and this one, and resonance structure is also there, though this is comes first. Without resonance structure is there, so it goes to third, and there is nothing is there, only CH alkyl group is there, it goes to 4. This is the order of this one. Okay, and then 15th one, benzyl alcohol benzoic acid orthocresol OHCH3. See, benzoic acid, there is a no CH2 group is there, but if you compare these two, the CH3 group is there, extra CH3 group is there, and OH is also there. Okay, if you have to compare acid and alcohol with OH3 group. Okay, that which one will come first? Acid only. Acid will take first position, and then this one. Why? It becomes a phenoxide and it will goes to the resonance structure. But in this case, this is not possible. CH2 group is there, the resonance structure is not possible. So this goes to 2 and this goes to 3. Here the resonance structure is also possible here, and it easily cleaves. Okay, it withdraws electron towards the benzene ring, so this will easily cleaves. Okay, after adding the base, this will easily cleaves. This phenoxide ion undergoes the resonance structures. This is the 615. The next one is 16. Orthochlorobenzoic acid, metachlorobenzoic acid, parachlorobenzoic acid. See here, if I'll write the structure, you can easily say, if it is in the name, you have to write, and then only you can able to find out. Okay, everywhere chlorine group is there, electron withdrawing group, so increase the acidic character, but the distance is the matters over here. If it is very closer, that is the first one. This is compared to this is closer, this is away from that. Okay, the inductive effect falls off with the distance. Okay, and the next 17th one, phenol, nitrophenol, phenol, para-nitrophenol, para-cresol. OH will be there, CH2 should be in the para position. Okay, this is para-cresol, and then cyclohexanol. Cyclohexanol. First one, so this is the electron withdrawing group is there. Okay, if any other group which is having electron withdrawing group, no, this is the one which is having electron withdrawing group. So the first place goes to this only. And the next one, this is only phenol, this is CH2 group is there, this is cyclohexanol. You have to compare these two. In these two, your CH2 group is there, this is electron releasing group, so it comes to the last. Leave it like this. You have to compare this and this. Which one will come first? Here the phenol is there, phenoxide ion, it goes to resonance structure, this will comes as a second one. And here, this is the third and this is the fourth. And 18th. Para-methoxybenzoic acid, para-nitrobenzoic acid, para-methyl benzoic acid, the last one para-chlorobenzoic acid. Now we have to compare these three groups. This is, you know, that electron releasing group, so it comes at the last one. This is also electron releasing, this is also electron. We compare to this is more electron releasing compared to this, so this will comes as a last one, and this is the next electron releasing group and comes to the third. You have to compare this and this, which is a more electron withdrawing group, which is first, it comes in the electron withdrawing activity. So in that nitro, it comes to that. Why? Additional resonance structure is also there in the nitro, but that is not possible in the chloro. So this is first and this is second. Very clear? And 18th one, para-methoxybenzoic acid, para-nitrobenzoic acid, like a similar one, no? But it's different. Para-methyl and para-chloro. And then benzoic acid. Now we need to compare. As I said in the earlier case, this goes to the last. Five compounds are there, this goes to the last. And next to that, this will come, third one. And then first in that, if nitro group is there, so this is the first one. And second one, this one. Third one, only benzoic acid. So this is the order. Okay, 1, 2, 3, this is the fourth one, and this is the fifth one. Okay, clear? And next one, 19th, methane, phenylacetylene, ethylene. Phenylacetylene and ethylene. Just see here one more trick is also there here. I didn't explain in the trick. What is that? Increasing the S character. Increasing the S character increases the acidity. Increasing the S character increases the acidity. Here if you see that this is sp3 hybridization. Okay, if you compare the hybridization, okay, if hybridization increases the S character, increases the acidity. Here the S character is how much is there? It's nearly 25%. Okay, and remaining 75% is sp3 or p orbital is there. Here if you see this second compound, okay, in this triple bond is there. So what is that? SP hybridization. So if SP hybridization means 50-50 is there. So S character is 50%, S character is there. In here, if you see here SP2 hybridization, here is 25%, here 50%, here 33% nearly, 33% hybridization is there, S character is there. So according to the S character, it will increase. So which one will come first? Acetylene will come first. If S character is 50%, then that is comes first, and then 33%, and then 25%. So 25% what is the last one? Methane. And 33% is what? sp2, that is CH2 double bond CH2, and then triple bond comes first. Okay, triple bond comes first, second, and third. And the next one, this is 19th one. Now we are going to see the 20th one. See, this is little bit difficult, but it's a very good question. Nitrogen 2 amino group is present. Okay, and then imidazole group, quaternary ammonium salt. Okay, and that methyl group is there. Quaternary ammonium. Here also one methyl group is there. Here also one methyl group is there. Here also one methyl group is there. Here salt. Okay, which one will comes first? Which proton is more acidic? Here proton is there. Which proton is more acidic? This one or this one or this one? Which one is more acidic? Give the explanation also. Very simple. We can say that here the resonance structure, here also the resonance structure is there, and this resonance structure is spread to this side also. Resonance structure is there. So because of this resonance structure, this proton is easily cleaves from this nitrogen. So this comes as to the first. And again it comes to the next one. Here if you see this, here two carbonyl group is there. So because of the two carbonyl groups near to this this carbon, it easily cleaves the hydrogen. Okay, decreases the negative charge. What will happen? These two carbonyl groups withdraws the electron from this carbon atom, and it becomes easy to positive. Positive easily cleaves. That decreases the negative charge and easily cleaves. And comes to this, here the quaternary ammonium salt, here the resonance structure is also not possible over here. So this comes to the last acidity. This is the first one, this is the second one, this is the third one. Thanks for watching.